Question 21 says which of the following statement is not true. So four statements are given to us. The student, the fourth statement here is incorrect. It says if the internal forces are conservative, the work done by internal forces is equal to the change in mechanical energy. In fact, the work done by internal conservative forces is equal to the negative of the change in potential energy. This is a statement that we should remember. And hence for this question, dear student, the correct answer should be option number 4. Moving on to the question number 22. In question 22, a particle is moved from origin to A, A and the force is given. So two paths are there. Path 1 is OP and path 2 is OQP. Let the work done be W1 and W2. Then, since this force is a constant force and hence it is a conservative force. This means that the work done will be simply dependent on the initial and the final position and not on the paths taken. Therefore, simply W1 will be equal to W2 and hence for this question the correct answer will be straightforward option number 1. Now let us solve the question number 23. In question 23, the minimum work done to accelerate a truck on a horizontal road from rest to speed V is. Dear student, the minimum work done will be equal to the change in kinetic energy. So the W1 will be equal to the final kinetic energy half mv square minus initial kinetic energy, that is 0. So that is half mv square. Now the work done to accelerate from v to 2v will be half m2v square, that is the final kinetic energy minus initial kinetic energy half mv square, that will be 3 by 2 mv square. We can clearly see that W1 is less than W2 and hence for this question the correct answer is option number 1. Now let us solve the question number 24. In this question, a dam is situated at a height of 550 meters above sea level and supplies water to a powerhouse which is at a height of 50 meters above sea level. 2000 kg of water falls on the turbines per second. What would be the maximum electrical output of the powerhouse if the whole system were 80% efficient? Dear student, the power output will be the efficiency multiplied by the total power, that will be mgh by t, that is the work done by time. So this will be equal to 0.8, that is the efficiency, multiplied by the m, that is 2000, into g, that is 10. H is given to be equal to 550 and time here, dear student, is we have to take to be equal to 1 second. So that will be power, because it is given that the waterfall is per second, and this will be equal to 8 into 10 raised to power 6, that is 8 megawatt. And hence for this question the correct answer is option number 1. Now let us move to the question number 25. Question 25 says a block of mass m is attached to a massless spring of force constant k. The block is placed over a fixed rough inclined surface for which the frictional coefficient mu is given to be equal to 3 by 4 and the mass is initially at rest. The block of mass capital M is released suddenly from rest with spring in unstretched state. The minimum value of capital M required to move the block up the plane is. Now let us solve this question. The student, as long as the block of mass small m remains stationary, the block of mass capital M released from rest comes down by 2 mg by k before it comes to rest on its own. So this will be coming down by 2 mg by k. If this extension produces enough force so as to move the small m, then this will be the minimum value of capital M and it will help us to find out our final answer. So herein 2 mg by k into k, that is the spring force, should be equal to the net downward force on small m, that is mg sin theta plus mu mg cos theta. Here k and k will get cancelled out. So 2 capital mg will be equal to mg into 3 by 5 plus mu, that is 3 by 4 into mg into 4 by 5. Now dear student, on solving this we get a value of capital M to be equal to 3 small m by 5 and hence for this question the correct answer should be option number 1. Now let us move to the question number 26.